Okay, so, it is now time for the keynote talk of VMIL 2023. So this year, the keynote speech will be delivered by Shigeru Chiba, who is professor at Graduate School of Information Science and Technology at the University of Tokyo in Japan. So for one of his work, Javassist, which was originally published at eCoop 2000, Professor Chiba recently won the AITO Test of Time Award as a recognition of the large and lasting impact that Javassist had on the field of programming languages. Professor Chiba, thank you for accepting our invitation, and the stage is yours.
Okay, thank you for... So thank you for kind introduction, and also I would like to thank for this invitation. That was a very good motivation to fly to Europe from Tokyo this time. Well, so anyway, so I would like to talk about polyglot programming through foreign function interfaces. So nowadays, polyglot programming is everywhere. So it's to me, it's like a Cambrian explosion. When I was a student a long time ago, in the previous century, the world was dominated by C and C++. Well, some small talk at that time, and Lisp. Some people are allowed to using Lisp, but many people industry people are using C and C++. But nowadays, we have to deal with lots of languages, and also at the university, we have to teach many languages, not only C and C++. So that's nice. And this workshop is workshop on virtual machines. So I believe many more people here labs to use a single virtual machine, which should rule them all. Yes, that's right. For example, GraalVM is a very nice seminar work. And nowadays, you can run almost any kind of languages on top of Java virtual machine, like Java, not only Java, Scala, Groovy, but also Ruby, R, JavaScript, and C and C++ on top of Sulon. That's great. But I would like to give a question. So why do we need polyglot programming nowadays? And I think one of the main reasons is libraries. Nowadays, libraries are a big thing, I guess. And in particular, many programming languages, many of the nice programming libraries are non-pure libraries. For example, Python provides PyTorch, TensorFlow before, but those libraries are not written in Python. It's basically C libraries, but C libraries is wrapped around by Python code. And so we believe that's Python library. And many machine learning people and many young students want to learn Python to use PyTorch for machine learning, which is a very, very trendy topic. But they are not interested in Python code. They are interested in C code behind Python library, Python code. Same for MATLAB. Matplot. Matplotlib is a very convenient library, and many data science students are using Matplotlib on top of Python. But again, the core of that library is written in C and C++, and the Python code is just wrapper of them. Another example is JavaScript. I think JavaScript is one of the major languages today, DOM is very convenient and very nice libraries for graphical user building a graphical interface. But DOM is written in JavaScript, yes, but most of the DOM code, DOM library is written in C++ as a part of the browser. So it's JavaScript library, but if you want to say, I want to use a JavaScript for using a DOM, maybe this solution might not be very appropriate, because the motivation to do the polyglot programming is to use kind of non-pure libraries coming with some major languages. Of course, yeah, people are working on the topic for this scenario, like a song, by using song and libpython. But today, I focus on polyglot programming on multiple VMs. So in this scenario today, I want to use standard off-the-shelf VMs and to use libraries coming with the standard ones. And for that reason, I would like to use multiple VMs by programs communicating with each other through following function interfaces. So not use one single very great VM, but I want to use, in this context, I would like to say we want to use multiple VMs, multiple standard VMs, JavaVM and Python VM and Ruby VM and also JavaScript VM or Node.js. And I want to enjoy libraries, non-pure libraries on top of that. So that's the context of my today's talk. So in that context, I would like to pick up a few topics. There's two topics related to this scenario. One is the design of a polling function interface, and the other one is a collaboration among memory managers coming with those off-the-shelf VMs. The first issue is the design of a polling function interface, which is not only for the polyglot programming on top of multiple VMs, but it's also applicable to polyglot programming on a single VM. But this design issue is more serious issue in the context of polyglot programming on multiple VMs. So let's start the first issue. So this one was work presented at Gypsy several years ago. So I am a Ruby programmer today. Well, not really. It's like, because I'm from Japan, and Japan, the Ruby was invented in Japan, and many core developers of Ruby is still in Japan. So many of my friends are working for that, so I like to pretend I'm a Ruby programmer. But, all my friends working for Ruby are not good at Ruby programming, because they are basically C++ programmers, because they are developing a Ruby VM. And many people ask them, how to write this Ruby code for Rails. They can't answer. But anyway, I want to use Python libraries for machine learning and data science, PyTorch or Matplotlib. Although, of course, similar libraries are provided for Ruby, but unfortunately, they are not very powerful. So I want to use Python libraries from Ruby. And one guy implemented the FFI, foreign function interface for Ruby, which allows Ruby code to call Python code in a very flexible way. So here is an example. So suppose you wanted to use matplotlib in Python, and the code below is a Python code I copied from some website, tutorial website. And as you can see, you can write very, very similar code in Ruby to use this Python library. So that's the power of foreign function interface today. It's nice, but there is a pitfall. So for example, suppose you want to use a deck library from Python. In Python, you write like that, dq equal deck parenthesis bracket 235. It makes a deck containing 2, 3, and 5. In Ruby, you can call that deck function. You can use a deck library in Python by using foreign function interface, but you have to. Unfortunately, you can't write like the code like Python. In Ruby, you have to add some extra dot after deck, deck dot parenthesis. This is because this is nice, due to the very flexible syntax provided by Ruby. But if you forget that, your program crashes. Or you have to, actually, the meaning of dot is to call new method on deck. So it's so basically you have to create some object through a deck variable, which is a reference to a Python object. But so you have to write that. Another pitfall. Both Python and Ruby provides keyword argument, but the syntax is slightly different. So in Python, again, to use matplotlib, you want to write that kind of code. You know, you want to call plot with some LW equal 5. LW is a keyword argument. In Ruby, you can call that library through foreign function interface. But you have to be careful. You have to write, because the syntax of keyword argument in Ruby is different from the keyword argument in Python. You have to write LW:5, not equal. This is a very minor difference, but it's a big pitfall when you write Ruby code using foreign function interface to call Python library. And the worst thing is you can write LW equal 5 in Ruby, but in Ruby, that's a kind of assignment to LW. So it works, but the result of this code, the result of this code is different from what you expected, and it's going to be hard to debug. So this pitfall is not a simple thing. I have another example. Sorry. Dictionary. You can call, suppose you want to use a TensorFlow. TensorFlow is nowadays a little bit old library. The progress of machine learning is so quick. But when I wrote this paper, TensorFlow was still kind of a popular library. In Python, first of all, you import TensorFlow. And first, you call session function to create some object, tf.session. And then you can run it with kind of extra parameters with xData argument, whose value is 2.0. In Ruby, you can do the same thing by using foreign function interface again. But first of all, you have to call new. You have to add extra keyword new. Instead of just simply do the same thing as in Python. And the more serious pitfall is the last line. To make a dictionary, you have to use a row symbol instead of a colon. And if you're sloppy guy, and if you write x data colon 2.0 for Ruby, it works. But the result is different because in Ruby, so the meaning of this function is x data is not the label. It's just a kind of returned value from the third line, fourth line. tf.placeholder returns a value, and it is assigned to x data, and the pair of x data and 2.0 has to be passed to a run method. If you write this code in Ruby, the semantics of the dictionary construction is slightly different from Python. And the meaning of this case is it's a dictionary. In the dictionary, the key is x, the string constant x data. And this dictionary has a pair of string x data and 2.0. So it's different from the data expected by the run function, so it doesn't work. So all in all, okay, these examples are not artificial. These examples are not examples I try to find or I try to come up with by careful reading documents. I found these mistakes in some blog entries on the internet. So because one guy implemented a foreign function interface for Ruby, and that got popular. But many people try to use it for using TensorFlow and other nice Python libraries, and got the problems. And it's very hard to fix bugs. So basically, Ruby users use Python libraries. When Ruby users use Python libraries, basically they first Google and find some blog entries or Stack Overflow entry, and to find how to use a Python library, because they are not Python guy, they are Ruby guy. And they tend to copy and paste sample code found in a tutorial and run it, because they believe foreign function interface deal with everything smoothly. So that's why they wrote this kind of code, right? Because they found the Python sample code, in a tutorial, and just make a copy. And they don't really care about the detailed differences of the syntax between the two languages. Well, they know, but it's... So the question is how to avoid these pitfalls. Can we do that? Can we do that? So my observation is, well, foreign function interface is very popular technique to do polyglot programming. But maybe function is not right abstraction nowadays. Well, it might be nice in the era of C libraries, C++, C++ is not really, but in old C libraries days, it should be okay. But now we want to use libraries written in a different language like Python, JavaScript, maybe Ruby for Rails. So my observation is maybe function is wrong abstraction. This is not because Ruby's syntax is very similar to Python's, because all the examples are due to very minor differences between Ruby and Python, or similarities between Python and Ruby. But I believe this is a more serious issue. One of the reasons of the pitfall is that Ruby users expect arguments are also Python code, because they copy and paste. So first of all, the first line is they call tf.session, which calls session. They expected this is a Python code because they are using Python library. But it's not really Python code. It's run in Ruby, and it's interpreted in the semantics of Ruby. And all the method lookup stuff is done in Ruby, under the semantics of Ruby. So that's one of the reasons why some pitfall happens. The second one is also true. From the user's viewpoint, Ruby's user's viewpoint, Ruby user's viewpoint, they wanted to run a run method in Python library with some parameters. But the arguments are computed in Ruby. Yes, we are programming language guys. The first thing we learn at the undergrad class is, okay, argument is evaluated at the cola side, not the coli side. But in case when you copy and paste the Python sample code into Ruby, they often tend to think that it's part of the Ruby, it's Python code. But again, this argument expression is interpreted in the context of Ruby, so that makes a problem. So our idea solution is pretty simple. So maybe for polyglot program, in the context of polyglot programming on top of multiple VMs, we should be able to do that code migration rather than foreign function interfaces to avoid pitfalls I presented before. And because I cannot talk, I would like to say, well, future VM people should consider this, and they should implement their own VMs to enable this kind of code migration to support polyglot programming. Well, the rest of the idea is pretty straightforward. So, for example, this is a very simplified version of the idea. So instead of, well, foreign function interface gives you a nice looking code, but to avoid the pitfalls, you should be able to write that kind of code. It's like when you want to call Python library, you should say, maybe put some keyword like a run Python and curly brace and write Python code. And in this case, the code within the curly braces should be interpreted in the semantics of Python, not Ruby. But because this is a foreign function interface, it's still a kind of foreign function interface. So I would like to say, this code should be still valid Ruby code. In other words, I like to use embedded DSL based on hosted by Ruby rather than pure Python code, because you can expect editor support and also IDE support if the code is written in embedded DSL hosted by Ruby in this case. So in that sense, it should not be string embedding. String embedding is one of the techniques to implement embedded DSL. The idea is simple. When you do that kind of thing, just pass a string constant to some function. And in this case, run Python takes a string constant, which is Python code, and just send it to Python and run it. So it's very straightforward. But if you use a string embedding, you can't enjoy any library support. Editor support or IDE support. So I still say embedded DSL should be nice. And also, in typical string embedding, you would not be able to write this kind of code because LST is Ruby variable, and the code embedded in the string refers to LST, but usually it's not possible in the typical string embedding DSL, but that should be possible. So we wrote, So another example, it's a more complex example is with, because Ruby provides very flexible syntax, you can stay in the embedded DSL even if you wanted to use a very complex syntax provided by Python. Ruby, as you know, Ruby doesn't provide the with statement, but because Ruby provides very flexible syntax, you can pretend with statement by using some complex Ruby syntax. And so it's possible to write it in the context of embedded DSL hosted by Ruby, but run Python code takes that function and do some complex thing and send it and interpreted it in the similar semantics of Python and send it to Python and get the result. We wrote some simple library called Yadorigi, which allows you to write this kind of embedded DSL. So the idea is very simple. It's this library provides just one function, refi, which takes a lambda function in Ruby, and generate abstract syntax tree of the function. So that's it. The mechanism of this function is only that. But if the every future VM provides this mechanism, you can implement some nice embedded DSL on top of the host language and minimize kind of pitfalls caused by the differences between two languages. Well, so just for someone who knows Lisp macros, they might say this is the same as a Lisp macros. Yes, but the Lisp macro is basically takes an abstract syntax tree and returns abstract syntax tree. But this refi mechanism takes a function. It's a kind of first-class function and returns the abstract syntax tree. So you can write some convenient function to provide a better programming interface and so on. So it's a minor issues. Anyway, move on. So that's one thing. And the second thing is collaboration between memory managers of the multiple VMs for polyglot programming. So this was the work presented by us at this year's PLDI. So it's a little bit new. Again, I'm a Ruby programmer today. And I wanted to use a DOM library in JavaScript for building nice graphical user interface on web browsers. Well, Ruby provides the old TickleTK library. That's a kind of very old-fashioned library for my generation. It was very popular in the previous century, but now we are in 21st century. So TickleTK library is not nice. You know, today the best user interface is web browsers. So we want to use DOM library to implement some graphical user interface for Ruby. So in this case, I myself implemented the foreign function interface between Ruby and JavaScript. I believe that's a nice library, and it's open source. So you can, by using this library, you can write a Ruby code which runs in an independent process and calls and invokes a standard browser like a Safari or a Chrome or a Firefox as a separate process. And the Ruby programs communicated to the browser through a kind of socket, TCP/IP or socket, and draw any kind of web page by through the FFI. So look at that code. It's more like, it's a Ruby code. But it's more like JavaScript, if you know the JavaScript. You see a title and button are Ruby variables, but it refers to JavaScript DOM object. And you can call any method on those variables and manipulate web pages. So it's nice. It was nice. And you can write this kind of sample code. You can put some button on the browser page and let users click that button and do something. Nice. But as you know, event handlers is a very easy way to make a cyclic references, and which causes a cyclic garbage. And typical FFI implementation makes a memory leak. You see, so here left-hand side is a Ruby code and right-hand side is JavaScript. And because that code is written in Ruby, but if you run this code, in Ruby, you make a callback object, and that refers to button DOM object, which is in JavaScript. And of course, the button object in JavaScript refers to Ruby object because it's a callback function. So it makes a cycle. And the typical FFI interface uses a kind of reference counting garbage collection. So it's easy to make a memory leak because reference counting GC cannot reclaim cyclic garbage unless you use some tricky things. Yeah. And the reason we have to use a reference counting garbage collection for FFI is because these two programs are separate processes, and there is no way to look at the memory heap in the opposite side. So that's a problem. The people who pointed out this problem was not me. This problem was presented by different people at UPSA 18s 5 years ago. They are Google people, and they are developing V8 VM and also Blink HTML renderer. And because, well, from our viewpoint, the DOM library is in JavaScript, but from the implementer's viewpoint, JavaScript is run on V8 VM, and HTML renderer is running in a separate component, which is Blink in the case of Google Chrome. So their solution was, they proposed a cross-component tracing. So their solution was to modify V8 and Blink for remote tracing. As I said, reference counting is not good at reclaiming cyclic garbage. So they modified the V8 and Blink memory managers and let garbage collectors traces references between V8 and Blink, because both of them are in the same process. So it's possible. It's technically possible, although from the software engineering viewpoint, it's not an easy thing because the two components are developed by separate teams. Although they are both working for Google, but Google is a big company, so they communicate each other and try to minimize the modification of the components to enable this. Nice, yes, presented at UPSA, great. But unfortunately, we are not employee of Google employee. A bunch of my previous students are working for Google, but I don't have any ways to ask them to modify V8 for us. So we have to find a solution which doesn't modify V8. Good news was I have a very good connection to Ruby people. So it's possible to change Ruby VM, although Ruby's garbage collector is also a production VM, production garbage collector. So it's very difficult to modify it. But changing a VM bit is okay. I just write an email to my friend. I have this problem, and do you have any good ideas to customize a VM, Ruby VM? And he told me there is a function, right? It was not exposed, but it's easy to use. So our idea is to implement some coordinators between V8 and Ruby's garbage collectors without changing garbage collectors. And so because we can't modify the V8 garbage collectors, so we cannot implement some remote tracing. But idea is pretty simple. So we make a kind of local reference graph in Ruby and copy that graph into V8 world and ask V8 garbage collector, okay, to trace them and reclaim garbage. And of course, this is very may come with a big overhead, but we assume the remote references are not many, because in a scenario, we just want to use the DOM libraries in JavaScript. Most of the code is running in Ruby VM. Just want to use, DOMs. So the number of remote references are not many. So it's not a really, complex polyglot programming. So that's why this idea works. Let me simply show the brief overview. So here, look at that B object, which has some icon of pin. It represents reference counters. So because the reference count, the number of reference count is more than 0, so it is pinned down to avoid accidental reclamation. So basically, garbage collector, both Ruby garbage collectors and JavaScript garbage collectors look at only local references. So that's orange, just rows. And to avoid the reclamation of B, object B, we use reference counters. But what we really want to do is global tracing. We want to ignore reference counters, and just we wanted to look at rows and over across the Ruby and JavaScript. And the idea is just copy the kind of part of the object reference graph in Ruby's at the Ruby side to JavaScript and ask the Ruby JavaScript garbage collector GC to trace all the object graphs and reclaim garbage. So that's an idea. So, and let me show a little bit more complex case. So look, this is an example. We have a bunch of objects, and in this example, garbage object F, G, H, I, and J are cyclic. It makes a cycle, and it's a garbage. So the goal is to reclaim them. So first of all, we make a reference graph. So blue one and green ones are reference graphs. So the basically reference graph is a local reference graph in Ruby. And to make this graph, we had to modify a Ruby VM. But the modification was very, very small. We didn't modify the garbage collector. And the tricky thing is, so we first run a normal tracing. So it makes first we trace is a blue. I mean, we count up, we enumerate all objects reachable from the Ruby root. Okay? And in this case, object C has to be live because it's reachable from Ruby. And after that, we look all the incoming reference from JavaScript to Ruby, in this case, a reference to object I, and traces all the references from I, and to see which outgoing reference from Ruby to JavaScript exists. So in this case, object G is reachable from H. Look at the reference from F and G, from F to B. This is not traced because anyway, object B is reachable from the root, so we can ignore them because the goal of this idea is to reclaim cyclic garbage. So we can ignore all the blue objects. So this is why the performance overhead is not large. Because most of the live objects in Ruby side are reachable from the Ruby root. So we have to run kind of tracing from the root, but the tracing green thing is not a big issue, big thing. So after that, we copy kind of blue edge and a green edge to the JavaScript side. It's compressed. You know, it's not the whole, we don't really copy all the Ruby objects into JavaScript side. We just simply make a copy as a kind of graph, you know, from and to. So this double edges are a row. And run a garbage collector in JavaScript, and suppose the JavaScript garbage collector reclaims object G and H, because they make a cycle, but it's not reachable from the JavaScript root. That's it. And then after that, because the JavaScript objects are reclaimed, Ruby objects I and J and F are also automatically reclaimed by using some normal reference counting. And after that, we restore all the reference counters, you know, in this case C, and run a mutator again. So that's it. Well, at the beginning, we worry about the performance overhead, but as I said, most of the live objects are reachable from the Ruby root. So the actual performance overhead was not large. So it works. But when I tested the many benchmarks and examples, we found that in a real system, this should not work. This didn't work. Because this algorithm assumes that we can run a garbage collector in JavaScript. We can run a full garbage collection in JavaScript just after copying object graph, reference graph. And after the garbage collection finishes, we restore all the reference counting and run the code again. But as you know, a modern garbage collector is very complicated program, and it's not realistic to assume that. And we are not really sure, but according to our observation, to implement this reference counters, we use a lot of weak references. And JavaScript garbage collector seems to recognize weak references accessed just before the garbage collector starts as strong references. So to make all the things, you have to touch all the remote weak references, and that makes all these references strong references, and then JavaScript garbage collector ignore those weak references. So that's why the system didn't work. So we had to come up with improvement. So we stopped running garbage collector just after copying reference graph. We just copy a reference graph to JavaScript, and before JavaScript garbage collection starts and finishes, we resume mutators in Ruby, mutator threads in Ruby and also JavaScript. And of course, this is problematic in case because a mutator thread may change a reference graph in Ruby just after copying a reference graph and before restoring all the things. So we have to copy. We have to maintain the copy of graph in JavaScript be consistent with Ruby side. So here's an example. Now we have a graph from C, D, E, F, and G. And so because according to the algorithm I presented, so we make a reference graph and copy the graph into JavaScript. Looks okay, but now we resume all the Ruby threads before finishing this garbage collection. So after resuming a JavaScript thread may call a method on B with an argument which is a reference from C to D. So basically, JavaScript program may pass a remote reference from JavaScript to Ruby object as an argument. So which is very problematic. Because the receiver method, the called method B on B receives a remote reference from JavaScript to Ruby. So they may use it, and they may make a new reference from B to D in Ruby side. And now, kind of reference graph in Ruby is changed. We look at the green one. So now we have a reference from we have a path from A, B, D, E, F, and G. So according to our algorithm, we have to make a kind of copy of reference graph in the JavaScript side to make it consistent. So in that case, a reference has to be, we have to have a reference from A to G. But because this change was done after copying a graph, so it's not reflected on JavaScript side. So after that, JavaScript program may delete a reference from root to C. In this figure, it's named Q. So then, JavaScript garbage collector may reclaim C and G because they are not reachable from the JavaScript root now. But from the viewpoint of a global reference, object G is still alive because we have a path from A, B, D, E, F, and G. So that's problem. So our solution is to install some sort of a barrier. We named it a kind of send barrier because in this case, we have to detect when a JavaScript program sends a remote reference from Ruby to Java, to Ruby. JavaScript to Ruby. So our barrier monitors all the arguments and see whether that argument is a remote reference or not. And if it's a remote reference, they stop the kind of copying and restore all the reference graphs, reference counters, and so on. And it cancels the garbage reference counting garbage collection. So, so if we properly install this send barrier, when JavaScript program passed the remote reference from C to D to B, copied reference graph is eliminated, and all the reference counters are restored, and everything works well. Although we lose the chance to reclaim C later. We lose the chance to reclaim some cyclic garbage, but later we assume that reference counting garbage collection is run again, and finally they are removed. Well, it's time to stop. So, well, I quickly introduces our work on polyglot programming in the context of the use of multiple VMs. Again, to summarize, I would like to say one of the big reasons to do the polyglot programming is to use their non-pure libraries. I mean, libraries written in C and tightly integrated within a virtual machine. So to do that, we have to consider the design of foreign function interface. As I said, function might not be the best abstraction in this case. Maybe code migration is a better abstraction. So the future VM should support that kind of foreign function calls or code migration, as I said. And the second topic was memory management. Well, if you run all the programs written in different languages on top of the single VM, we don't have to care about memory management because memory management is done by that single VM. But in my context, we have to run the multiple VMs. Some are separate processes, some are in the same process, but still from the software engineering viewpoint, integration of the two memory managers is not simple work. So in that case, our proposal is to introduce some collaboration framework between memory management. We had to modify the Ruby VM because basically Ruby VM doesn't provide a mechanism to implement our algorithm. But again, future VM should provide some interfaces to support remote cross-component tracing proposed by Google people, or reference graph garbage collection. So that's my talk. Thank you.
So is there any question?
Thank you. That was a very enjoyable talk. Near the start, you suggested that one VM to rule them all wasn't a brilliant idea.
Well, I never say it's not the brilliant idea.
Sorry. Okay. But that one VM you were thinking about was the JVM. Do you think WebAssembly might be a better single VM to rule them all? That's one question. And the second question, if I may, very quickly, how do you get around the n squared problem where the notion that for every pair of virtual machines, you'll need to engineer a distinct foreign function and kind of bridge between them? Thanks.
I lost your point. So, do you?
If you have 5 other languages, you need 5 interfaces. Each one needs interfaces for 5.
Yeah, that's a good question. So far we are focusing on the 2 VMs. We 2 VM scenarios, and for example, for memory management, we have to consider multi-party cases like 3 VMs, and also yes, as you said, the WebAssembly is getting popular. And if you use in a case WebAssemblies, you have you can easily make 3 or 4 components, and every component has their own memory manager. And in that case, you have to deal with many very complex situations. And well, actually, we are working on that, but we don't have any nice solutions so far. And I also got a message, contacts from other people who are also interested in such complex situation. So that might be a nice, interesting research topic in future. Yes.
Thank you.
Hi. So I think you were able to modify the Ruby VM for providing what you want, but didn't you need to modify like VA as well? Like, what was the thing that was there in the VA and was missing in the Ruby side? Like, were you able to check if the reference from the JavaScript is from the root or not without modifying the VA?
Well, our assumption was we don't want to modify the V8 at all. We want to use just off-the-shelf V8 engine. But the mechanism we need is to trace objects in that local environment. So if the V8, in the future V8 provides such a mechanism to implement some sort of tracing, then you can do the same thing. But in that case, the host is a JavaScript, a V8. And Ruby, we don't have to modify the Ruby VM at all. But our algorithm needs at least one language has to provide a kind of tracing mechanism and trace all the objects reachable from the root. And that's not available now, at least on V8 as far as I know.
Maybe I still don't follow. So why just only one of these requires the implementation of that? Because so you can communicate the root path from Ruby to JavaScript because you can modify Ruby, but let's say there's cyclic reference from both languages. How do you communicate the path from, say, from Ruby to JavaScript and then JavaScript to Ruby? You can go through from Ruby to JavaScript because you can modify the Ruby VM, but then if that goes back to Ruby, how do you know from the JavaScript reference that the Ruby object is? Okay.
So basically, remote references are implemented in a special way. Anyway, in this case, we actually, to simplify this explanation, I didn't mention that, but usually the object C is kind of proxy object. So its implementation is not the normal JavaScript object. So object C knows this reference is not a normal reference. It's not a local reference. It's a sort of it's a typical implementation in this kind of thing. So it knows that all the program, even the user level libraries can recognize remote references. But question is how to get the root objects. Some root objects are in the stack frames. And usually there is no way to list up all the objects reachable from the root. And that's pretty, from the implementation viewpoint of ZC, it's very complicated in case of concurrent programming.
Okay, thank you.
Hi, great talk. Maybe I misunderstood something or I didn't understand something. So in your view, what's the motivation in the case of the foreign function APIs to go from high-level language to high-level language to low-level language? For example, you mentioned the PyTorch case, right? Mm-hmm. PyTorch is a Python, let's say, face, if you like, to go to CUDA, DNN, or these low-level APIs for GPU programming. But in this case, you are going from Ruby to the Python to C or C++, right? So do you see that that's a better view, and what's the benefit of doing that?
Well, most of people are not care about the details of the implementation. They don't know how PyTorch is implemented in Python. They believe all the code is written in Python. And yes, you are good engineers, so you can just retract C libraries from PyTorch or TensorFlow and port it into Ruby. It should be easy to write some wrapper code.
Yeah,
but most of the people wanted to use PyTorch as it is. They simply just search Stack Overflow and get this kind of piece of code to use some.
Okay, I
nice
buy that. So you're mentioning because of the ecosystem, it's easier to find documentation in the high level part than in the low level part.
That's right.
Okay,
That's
I
right.
buy that. Yeah.
And
Because
I think that's very important nowadays.
I do agree. Yeah. Okay, thanks.
Thank you for your talk. Do you have any thoughts on the large-scale software engineering costs of systems that you build from different, possibly many languages? So in my experience, it's always very hard to, especially if you go slightly more exotic, maybe not Ruby, but R, and you combine that with something like JavaScript, TypeScript, it's really hard to kind of find people that actually can work on the combined system and just instead of just one part of it.
Yeah, but if you look at the history of the programming, many people are struggle with always polyglot programming. For example, nowadays, if you wanted to develop web services, you have to write a code in what is Apple language? I forgot the name. Yeah, and also Java for Android. No, it's not Java. It's and also SQL. Still, even nowadays, you have to write a SQL code for accessing a database. And sometimes if you're working for the financial industry, you might have to write a COBOL code to use legacy, system and so on and so on. So anyway, I know it's not a very good solution. As I said, as I said at the beginning, the best solution is to use a single VM. Single VM should rule them all. But in practice, we still have to deal with multiple languages and write appropriate code, because not all the software is written in open source. And every people has their favorite language. Some of my students love the Haskell, and he wanted to write anything in Haskell, and some others still like Python and so on. So that's my observation.
Okay, thank you.
Thanks. This is a question about the language syntax similarities between Ruby and Python. Mm-hmm. You showed near the beginning of your talk some blog articles where Ruby programmers were using the PyCall FFI, and they were using native Ruby syntax, and it was giving them the wrong answer because somehow that didn't map well onto the Python abstractions. So I think some of those examples you showed with your blog articles of 2018, 2019, and so on, does ChatGPT or large language models these days, do they make the same mistakes when you ask them to synthesize PyCall code in Ruby, or is it clever enough to do it properly? Have you investigated that?
That's a difficult question. I don't have any clear answer to that. But I still believe syntax is one of the fun part of the design of programming language. And also, it's a kind of, I often think my research area is not science. It's more like humanity, social science. Because, we programming language people propose many nice ideas. And, we've been proposing the best way to develop complex software so far, not only me, everyone. But some people, not some, many people are still, it's like it's a humanity, right? All the people still want to stick around the C and C++. For example, people working for embedded systems love C++, and not C++, C. They still love C. And web people love, well, it depends on the generation. According to my observation, people, well, it's not a good, politically good thing to talk about the kind of generation, but, well, my favorite phrase is that people tend to stay around the technologies which was the best in age 20s, or I say, when they first learned computer programming. So if the Python, for some people, Python is still best language because they first learned Python and they get excited. So they want to stay there. But unfortunately, technology is changing. And I believe that Python and Ruby are still good languages, and I love the dynamic programming. But if I talk to my young students, they love the static programming, right? Static typing, right? It's funny because Ruby and Python were sort of a language against old-fashioned statically typed world. At that time they got bored with static typing. At that time, type system was not very strong. Then so they are excited with Ruby and Python. It's very productive. But then they recognize that static typing is better for developing a large software. And that's young people saying that, well, TypeScript is great. They don't like JavaScript. But I say there are still pros and cons and benefits and drawbacks. So we have to deal with. So in that sense, we still have to deal with multiple languages. We have to select the best language for the applications. So that's my, sorry, it's not the exciting thing, but it's.
Any more questions? Okay, then let's thank one more time.
Thank you very much.